So in the last lecture we studied how to determine the microstates or term wave functions, or how to construct the microstate table, and how to determine the RS terms from the microstate table. Now we have seen the RS terms for T2 configuration from microstate table, and these are singlet G, triplet F, triplet P, singlet D and singlet S terms. Now we have to determine the total degeneracy or total multiplicity of these RS terms. So total degeneracy or total multiplicity of RS terms, and total degeneracy is obtained by using the equation that is twice L plus 1. So this part gives the total orbital degeneracy or total orbital multiplicity of the term, and second part twice S plus 1. The second part gives the total spin degeneracy or total spin multiplicity of the term. So we'll take the first RS term, that is G. So for this term we have to use the equation, the same equation. For this G term, we have seen that the orbital quantum number, that is L value, is 4. So by using this 4 we can put the value of L into this equation. So 2 into 4 plus 1 into this twice S plus 1 is nothing but the spin multiplicity, and which is already given in the term. So twice S plus 1 is equal to 0 because the total spin for this term is 0. So 2 into 0 plus 1 is equal to 1. So you may write the 2S plus 1 directly from this spin multiplicity of the term, that is 1. So it comes to be 2 into 4, that is 8 plus 1 into 1. So it is 8 plus 1, 9. 9 into 1, 9. So total degeneracy of the singlet G is 9. It means the 9 different arrangements of 2 electrons for the D configuration come under the singlet G term. Then next term is triplet F. Triplet F. And for this triplet F, you know L value is 3. So by putting these values, that is 2 into L, that is 3, plus 1 into spin multiplicity twice S plus 1, it is given. So it is 3, 2S plus 1 is 3. So it's equal to 3 by 2, that is 6 plus 1, 7 into 3, that is 21. So 21 different arrangements of 2 electrons with respect to their different spin values and orbital values come under the term triplet F. Then next term is triplet P. For this triplet P, you know L value is 1. So by putting the value of L in this equation, 2 into 1 plus 1 into spin multiplicity, that is twice S plus 1 is 3. You can use it directly. So it comes to be 2 into 1, 1 plus 1, that is 3 into spin multiplicity 3, that is total again 9. So 9 arrangements of 2 electrons with different ml and ms values come under triplet P out of 45 arrangements. Then next term is singlet D. For singlet D term, L value is equal to 2. So by putting this L2 plus 2 into 2 plus 1 into spin multiplicity twice S plus 1 is 1. So you may put directly here 1, and the answer comes to be 2 into 2, 4 plus 1, 5. This part, it is called as orbital multiplicity and this part is spin multiplicity of the term. So 5 into spin multiplicity 1 is equal to 5. So out of 45 microstates or arrangements, 5 microstates belong to singlet D term. And last is singlet S term. And for the singlet S, you know L is equal to 0. So the total degeneracy for singlet S comes to be 2 into 0 plus 1 into singlet. So spin multiplicity 1 is equal to 1 into 1. So total 1. So in this way, the total degeneracy 9 plus 21, 30. 30, 9 plus 1, 10, 40 and 5, 45 which we have determined from the microstate table and by using n factorial equation. So we can say that total degeneracy for D2 configuration is 45. Total degeneracy or multiplicity of or for D2 configuration is 45. Next, we will determine the spin orbit coupling values which are shown by the symbol G. That is spin orbit coupling or LS coupling, or it is also called as RS coupling. So LS coupling, J values arise. For these J values, the J values can be obtained by using the equation that is L plus S to L minus S. L plus S to L minus S number of J values are possible for the given term. So for the first term means the splitting of RS term further takes place into different energy levels due to this spin orbit coupling. So for the first term, that is singlet G. Singlet G, the J values for singlet G. So let us write down J values for singlet G term. These are obtained from their L values and S values and they vary from L plus S to L minus S. So for this first term, we know that for G, L is 4 and S is equal to 0. As the multiplicity is 1, total spin is 0. So by putting these values into this L, that is 4 plus 0 to L 4 minus 0. So J values vary from 4 to 4, that is only one J value is possible and therefore this singlet G term J value is shown as subscript. So singlet G4. So it is shown as with J value singlet G term. So there is no splitting of singlet G. It is just transformed as it is. Then the J values for triplet F. Triplet F, again L plus S to L minus S. For F term, L is equal to 3 and as the spin multiplicity is 3, S is equal to 1. Total spin 1, therefore twice S plus 1 is equal to 3. So is equal to L value 3, S value 1 to L value 3, S value 1. So J values vary from 3 plus 4 to 3 minus 4, that is 2. So possible J values are 4, 3 and 2. So the triplet F term is further splitted by LS coupling into 3 energy levels having J values 4, 3 and 2. Next we see J values for triplet P. For triplet P. For triplet P, for P term L is equal to 1 and for triplet term S is equal to 1. So we can write down these L values and obtain the J values as 1 plus 1 to 1 minus 1. So 1 plus 1 2 and 1 minus 1 0. So the number of J values from spin-orbit coupling for the triplet P term are 2, 1 and 0. Similarly, J values for singlet D. For singlet D term, for D term arises when L value is 2 and singlet term arises when S value is 0. So, for obtaining J values here 2 for L and S is 0 to 2 minus 0 to 2 minus 0. So here the values from 2 to 2 means only 2, that is there is no splitting but it is transferred as it is. Similarly for singlet S, for singlet S, for S term L is 0 and for singlet term S is also 0. So 0 plus 0 to 0 minus 0. So J value is 0. Only one for singlet. Here you can judge that for singlet G only J value, J is only one value and it is 4. Then for triplet F, spin multiplicity is 3 and 3 J values are obtained and these are 4, 3 and 2. Whereas for triplet P, spin multiplicity is 3, 3 J values are obtained and these are 2, 1, 0. For singlet S, singlet D, only one as the multiplicity, spin multiplicity 1, only one J value we observe and that is 2. Whereas for singlet S, again spin multiplicity is 1, so only one J value is obtained and that is 0. So in this way, the spin orbit coupling can lead to the formation or splitting of the term into different energy levels having certain energy difference. Now we will see out of these 5 terms or number of J values, which term or J value is ground state level, and that is for that we will have to see or study the Hund's rule or Hund's rules for obtaining or for finding out the ground state term, for finding out the ground state term for the given configuration. Here for this D2 configuration we are having the different terms, that is singlet G, then triplet F, then singlet D, then triplet P and singlet S. So out of these 5 terms, which is present at ground level, that is which has the lowest energy. So there are 3 rules from which we can determine the ground RS term. The first rule states that the ground state term has the highest spin multiplicity. So here in this case for D2 configuration we have obtained the 2 terms having the same highest spin multiplicity that is triplet F and triplet P. So which out of these two should be ground state? So for that there is second rule. So for finding out the ground state term, first you have to see the spin multiplicity and it should be highest. But if there are more terms having the same highest spin multiplicity, then go to the second rule, and this second rule states that ground state term also have highest orbital multiplicity. So these two rules are in parallel to the Pauli's exclusion principle and Hund's rule of maximum multiplicity. So according to this first and second rule, the ground state term is a triplet F. Now there is a third rule for finding out which J value is at ground state or is lowest in energy. So for this also there is the first rule that states that for the configuration or for the half filled or less than half filled, shell, that is energy level, the ground state or the lowest J value is at ground state. Shell, the lowest J value is at ground state or has the lowest energy, is at ground state or has the lowest state. That is, when the given configuration is half full or less than half full, then lowest J value is at the ground level. And second rule is that for the configuration which is more than half full, shell or energy level, the highest J value is at ground state, that is at lowest energy. So we have to follow these three rules for finding out the energy level sequence for the different J levels and for the different terms. So let us see the splitting of D2 configuration in terms of RS terms and the J levels. So here splitting of D2 configuration. So first D2 configuration, free metal ion. From the microstate table we have seen that total 5 states are obtained. And on the basis of Hund's rules, the ground state is, this is ground state, lowest energy, and according to first and second rule, the triplet F state is at ground state because it has the highest spin multiplicity and highest orbital multiplicity. Then from here we will write down the singlet G, triplet F, triplet P, singlet D and singlet S. So triplet F is the ground state, Then out of these four, again first rule to apply is the highest spin multiplicity. Therefore triplet P is next highest to the triplet F. Then the remaining singlet G, singlet D and singlet S all are singlets, and therefore we have to follow the second rule. The state which is having a term which is having the highest orbital multiplicity should be lowest in these three terms. So the highest orbital multiplicity term is singlet G. Singlet G. And next to singlet G, out of these two terms, both have same spin, but D has orbital multiplicity of 5 and S has orbital multiplicity of 1. Therefore, highest orbital multiplicity term, that is singlet D, will be higher in energy to singlet D, and remaining one, that is singlet S, will be highest in energy out of these 5 terms. Next, for the G values, we have to see the sequence of J values. This singlet S is simply transformed into singlet S, J value is 0. This singlet D is also transformed into singlet D, and we have seen that J value is 2. For the singlet G is also simply transformed into the singlet G, and the J value we have obtained, that was 4. But here this triplet P and triplet F have been splitted into three terms, 3 J values, and for the J values we have to determine the energy sequence following the third A and third B rule, B Hund's rules. So here triplet F, splitting triplet F, here triplet P and triplet P. So now we have to see the sequence of J values. For triplet F, 3 J values we have obtained, and these are 4, 3 and 2. As this D2 configuration is less than half full, we have to follow the 3A rule, that is, when the configuration or shell is less than half full, the lowest J value is at ground state, or ground state has lowest J value. Therefore, ground energy level will have lowest J value of 2. Therefore, triplet F2 will be at ground state, followed by triplet F3 and highest J value triplet F4. Similarly, for triplet P, we have obtained 3 J values, that is 0, 1 and 2. As again the D2 configuration is less than half full, the 0 J value will be at lowest energy. Therefore, triplet P0 will be followed by triplet P1 will be followed by triplet P2. So in this way, for the pre-transition metal ion having D2 configuration, the energy level sequence is like this. Triplet F, within terms, triplet F is at ground state, singlet S is the highest term, whereas in terms of J values, triplet F2 is at ground state and triplet F4 is at the excited or higher energy state. So in this way, we can determine the total degeneracy of the given configuration, total degeneracy of the RS terms. We can also obtain the J values, that is spin orbit coupling values or spin orbit interaction, and which gives rise to different energy levels, that is splitting of terms into different energy levels, that is having different J values, and in a summary we can show the total splitting in this manner. Thank you. झालं सर.